Okay, today we're going to talk about double angle and half angle formulas for sine and cosine function. If you remember from the previous section, the sum formula for cosine, so if we have cosine of alpha plus beta, that is equal to the cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Likewise, you can see the sum formula for sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine of beta. So we're going to use these sum formulas to derive our double angle formula. So let's start with sine. Okay, so instead of doing sine of alpha and sine of beta, the sum formula, I'm going to do sine of theta plus theta, which would give me sine of theta cosine theta plus cosine theta plus sine theta. So now let's see what happens when we derive this a little bit. So if we add this, we're going to get 2 sine theta cosine theta equals sine of 2 theta. So that is the double angle formula for sine. Okay, the way that we're going to derive the double angle formula for cosine, well, we know that cosine of theta plus theta is cosine 2 theta. And if we simplify the right side of our equation here, we're going to get cosine squared theta minus sine squared theta. That is the double angle formula for cosine. And there's actually some variations of this formula. Okay, because we know sine squared theta plus cosine squared theta equals 1, we can do some substitution here to get some other variations of this double angle formula. So cosine of 2 theta can also be equal to, let's see, if I substitute cosine squared theta in for 1 minus sine squared theta minus sine squared theta, I get 1 minus 2 sine squared theta. Okay. Also, I can substitute in for sine squared, okay, right here, which would give me 1 minus cosine squared theta. Alright, and then I could distribute here, and eventually I'd get 2 cosine squared theta minus 1. So you can see there's 3 different variations for the double angle formula for cosine. Okay, let's look at our first example here. It states if sine theta is 3/5 and theta is between pi halves and pi, find the exact value of sine of 2 theta. Okay, so we're going to use our double angle formula for sine, which is 2 sine theta cosine theta. Alright, we already know sine theta is 3/5, okay, and to find cosine theta, we can do that if we look at the unit circle here, we know that our triangle is in the second quadrant, where y is 3 and the radius is 5, and we're trying to find x. So we can use Pythagorean theorem to figure that out. X squared plus y squared equals r squared. X squared is what we're trying to find. Y squared is 9. R squared is 25. So x squared equals 16. And if we square root both sides, x is going to equal plus or minus the square root, plus or minus 4. Now, since we know that this triangle is in the second quadrant, x is negative, so we're going to say x is equal to negative 4. Okay? Now that we have theta in the triangle that is representing theta, we can figure out cosine. So cosine is going to be adjacent over the hypotenuse. And now we can just simply multiply. So 2 times 3 is 6, times negative 4 is negative 24, and 5 times 5 is 25. So sine of 2 theta would be negative 24/25. Now you try part B, cosine of 2 theta, and answer the question, and then I will work it out to show you if you've got the right idea or not. Okay, cosine 2 theta. So we have 3 different options for the formula that we can use for this one. Since we are given sine theta equals 3/5, it might be easiest to use 1 minus 2 sine squared theta. Don't have to, but this is how I saw it. So this would be 1 minus 2. We know sine is sine of theta is 3/5, and we're going to square that. So 3/5 squared would be 9/25. 2 times 9 is 18. 1 minus 18 over 25 would be 7/25. So cosine of 2 theta is 7/25.